Hi, this is Martha again. We're going to continue on page 11 of your lecture notes with some more examples. The first one is x to the 12th divided by x to the 3rd. We're going to subtract the exponent on the bottom from the one on top, so it's going to be x to the power of 12 minus 3, or x to the power of 9. On the second example there, y to the 3rd divided by y to the 20th is equal to y to 3 minus 20. Again, we subtract the exponent on the bottom from the one on top and get y to the power of minus 17. The exponent has a negative exponent, so we're going to move it to the bottom, and it becomes 1 over y to the 17th. On the next example here, we have y to the 5th power and y to the 2nd power on the right, and x to the 1st divided by x to the 3rd on the left. So for the y part of it, we're going to subtract the 2 from the 5 and get 5 minus 2, or y to the 3rd on the top. On the left-hand side with the x's, we have x to the 1st divided by x to the 3rd, so it's 1 minus 3, which gives us x to the minus 2. We could leave our answer as x to the minus 2 and y to the 3rd power, but for our practice test or test, we're going to prefer to take that x to the minus 2 to the bottom and have an answer of y to the 3rd divided by x to the 2nd. On the last problem we have listed here, we have 3, which has an exponent of 1, and 27 with an exponent of 1, so 3 27ths reduced to a fraction would be 1/9. We're going to divide the 3 by 3, which gives us 1, and 27 divided by 3 gives us 9, so that's the fraction part of it. Then we have x to the minus 5th. So I'm going to work this one a little bit different, and I'm going to go ahead and get rid of that negative exponent, taking it to the bottom, so it becomes x to the 5th. The y to the minus 6 has a negative exponent. I'm going to take it to the bottom. The x to the 2nd has a positive exponent. We leave it where it is. And the y to the minus 8th has a negative exponent. We're going to bring it to the top. So it looks like it does in the middle here. And at this point, we have a couple of different things. We have, for the x's, we have an example of the quotient rule. The x to the 2nd times the x to the 5th power, is going to be x to the power of 2 plus 5, or x to the power of 7. We have x to the 8th on top. We have y to the 8th on top divided by y to the 6th on the bottom. So it's an example of the quotient rule. We're going to subtract the 6 from the 8, and we get 8 minus 6, or we get a 2. So our answer is going to be y to the 2nd divided by 9x to the 7th. The other way that we can do this problem is to subtract the exponent on the bottom from the one on top. So it would be x to the minus 5th minus 2, which would be x to the minus 7th. And we would have y to the minus 6 minus a minus 8. That would make the minus 6 be a plus 8 for the minus 8. So it would end up being x to the minus 7, y to the 2nd power. And again, we could leave it like that with x to the minus 7, y to the 2nd divided by 9. That would be an alternative way to work that problem. On page 12, we have 3 different rules for the power rules. Again, x and y are any real numbers, m and n are integers again. So we have 3 examples of this. The first power rule that we're going to look at says that if you have one base and it has 2 exponents, so it's x to the power of m to the power of n, we simply multiply those 2 exponents together. So you'll notice the difference between the product rule. The product rule had 2 bases and 2 exponents. This one only has 1 base and 2 exponents. So an example of that is x to the 2nd to the 3rd. We're going to take the 3 and multiply it by the 2 and get an answer of x to the 6th. So I'm going to drop down here and look at examples of power rule A first. So our first one that we have under this is x to the 4th to the 3rd power. Again, 1 base, 2 exponents. If I wanted to, I could take my definition of exponents, which says that whatever is under this 3 is multiplied by itself 3 times. So it would be x to the 4th, x to the 4th, x to the 4th. Then I would have an example of the product rule, and I would add those together and get x to the 12th. A lot simpler, though, just to use the power rule, which says I can take the 4 and 3 and multiply them together and get a 12. X to the 5th to the 2nd power is 5 times 2 is x to the 10th. X to the 8th to the 3rd power is the 8 times the 3, or 24. Again, you'll see one base, two exponents. The next power rule that we have involves having more than one thing inside these parentheses to the 3rd power, and it really just expands on power rule A. So in this one, it says take each one of the products that are listed inside the parentheses and take them to the power that's on the outside. So this example would be 2 to the 1st, x to the 2nd, and all of that to the 3rd power. So first of all, we're going to take the 2, and its exponent times the one on the outside would be 1 times 3 for a 3. And then we would go to the x to the 2nd to the 3rd power, which is an example again of power rule A, which says multiply the two exponents together. So we're going to get 2 to the 3rd power, x to the 6th power. If we wanted to multiply out the 2 times 2 times 2 and get an 8x to the 6th, we could. The next example has 3 different factors or products inside here. So the 3 has an exponent of 1, the x has an exponent of 2, and the y has an exponent of 1. We're going to take each one separately of their exponents and multiply them by the 1 on the outside. So the 3 is going to be, it's 1 times 3, and it gets a 3. The x to the 2nd is going to be multiplied by the 3rd. So that 2 times 3 is going to give us a 6. And then we go to the y, and 1 times 3 gives us a 3 for its exponent. Again, if I wanted to write it out the long way, it would be 3 of these 3 x to the 2nd, y to the 1st multiplied. And again, we could use the product rule, go back, and get the very same answer. The answers are the same both ways. Probably a little bit quicker to use the power rule, where we take each one of the products and take its exponent and multiply it by the 1 on the outside. The 3rd power rule involves a fraction, and when you have a fraction, it says you take the top to the exponent and you take the bottom to the exponent. Again, the bottom can't be equal to a 0. So 2x divided by 3y to the 2nd power, and in this example, all of this, the 3y to the 2nd, should be on the bottom. So it's going to be 2 to the 1st, x to the 1st to the 2nd power, and on the bottom, it's going to be 3 to the 1st, y to the 2nd to the 2nd power. So we have the 2, the 1 times 2 gives us a 2 for x exponent. The x has an exponent of 1, 1 times 2 gives us an exponent of 2 for it. We go to the bottom, 3, its exponent is a 1, 1 times 2 gives us a 2 for that. And we go to the y, 2 times 2 gives us a 4 for that. Again, if we wanted to, we could make 2 squared be a 4 because it's 2 times 2, and we could make 3 squared be a 9, which is 3 times 3. Going on to the next page, on page 14, is just a summary of them for you. My recommendation is that you use this page and look at the difference between them. So the product rule has 2 bases, 2 exponents. The bases have to be the same, then we add the exponents together. The quotient looks like a fraction. The power rule, the first one has 1 base and 2 exponents. The second one has a couple of things in here, or it could be 3 or 4 or 5. But in this case, you take each one of their exponents times the 1 on the outside. And then the rest, the bottom one, power rule C, looks like a fraction. The top gets the exponent, the bottom gets the exponent, and then you go ahead and apply the rules. There are several problems for you to work in class or on your own. So I recommend that you try working these. There are a number of problems on page 15. You can go to page 16 and then check your answers. There are more problems on page 17 with their answers on page 18. If at any time you have problems or questions about any of these, you're certainly welcome to give me an email or shoot me a text message or make a phone call and ask about any of these problems that you have questions about. So that concludes the Week 2 Part 1 lecture notes. And when you pick up, we'll be talking about the Week 2 Part 2 lecture notes.